Hi Geometry, here we go. We're going to discuss angle proofs today. There's a lot to write down, so please pause this as we go through. There are four little converses that we want to talk about. And then just to talk about what a converse is when you switch the if and the then part of the statement. Okay, so if I have an apple, then it's a fruit. Or if I have a fruit, then it's an apple, right? And so sometimes it's true, sometimes it's not when you switch the if and the then, okay? And so let's talk about the converses here. So corresponding angles, converse of the original theorem, if two lines are cut by a transversal so that the corresponding angles are congruent, okay? So for example, if I tell you that this angle and this angle are the same, you can tell that they're corresponding, they're in the same spots from each other, well then that means that the two lines must in fact be parallel. You can go ahead and make that conclusion. The alternate interior angles converse says if two lines are cut by a transversal so that the alternate interior angles are congruent, well then you can conclude that the lines are parallel. So over here, for example, so alternate interiors, so like if this one and this one, and by the way, putting a little tick mark like this over the angles, that means congruence. So if I tell you that this is the case, that those are the same, well, this converse tells us that we can conclude that the two lines must be parallel. Okay, come down here to our last two. So we have the alternate exterior angles converse. It says if two lines are cut by a transversal, so the alternate exterior angles are congruent, well then the lines must be parallel. So alternate exteriors, so like this one and this one. If you start out knowing that these alternate exteriors are the same, well then you can make the conclusion that the lines are parallel, okay? And then last one, consecutive or same side interior angles converse. If two lines are cut by a transversal so that the consecutive and or same side interior angles are congruent, then the lines are parallel, okay? So same side interior, so that would be this and this, okay? If you see that going on with a tick mark like this, that will allow you to conclude that those two lines are in fact parallel. All right, so let's come over here and let's take a look at a couple of examples. All right, first one, find the value of x that will make m and n parallel. Well, if these two angles that have been labeled are the same, them being corresponding, that's enough for us to say that these two lines must be parallel. Okay, so this is a corresponding angle with this one, and so using the corresponding angles converse, we can set the 3x plus 5 equal to 65, and I think we'll get 3x equals 60, and divide by 3, so I think x is 20. All right, let's take a look at these two. So can you prove lines A and B are parallel? Okay, so let's just kind of think about this for a minute. Okay, look at where the placement is of the angles. Okay, so as you're looking at that placement, you can see that this one and this one, these are alternate exteriors. So if these are in fact the same, we can say that A and B are parallel because of the alternate exteriors converse. Okay, and then let's take a look at these ones. It looks like they're both in the lower right, and if those are the same, that's the corresponding angles converse, okay? That will in fact allow us to say these are parallel and these are parallel. All right, so let's take a look over here at a proof, okay? So to do a full proof here, all right, we want to prove, we're given that 4 and 5 are the same, they're congruent. We want to prove that G and H, lines G and H, are in fact parallel, okay? So remember, with these proofs, we always want to start with our givens. We were given that angle 4 and angle 5 are the same. Okay, so let's start there. Okay, next, another angle relationship we can confirm here is that angle 1 and angle 4 are the same. Okay, now look at their placement. How were we able to make that conclusion? Because they're vertical angles, and vertical angles are always the same. Angles that are opposite each other when two lines cross, they're always the same. Okay? All right, step 3. I think we can now say that angle 1 and angle 5 are the same. So 4 is the same as 5 and 4 is the same as 1. Well, then 1 must be the same as 5. You can see, of course, that that's the transitive property, right? If A equals B and B equals C, well then A should equal C, okay? And then I think our last step here is I think we can now in fact say that G and H are parallel, okay? And we can make that conclusion because of the corresponding, whoops, let me scoot this over for a second, corresponding angles converse. Okay, and so this is just one way of completing that proof. All right, so let's take a look at our last one for today. Find the value of x so that P and Q are parallel. Okay, so be careful with this one. Think about their relationship. What do we call these angles, right? Okay, think about that relationship. All right, and if you did it correctly, I think you should get 12. All righty, let's get to the practice.